Hi students, good morning to all of you. Today we are going to discuss about the unit number 5 of smart electric grid. The name of the unit is distribution management. In that we are going to study about the topic of distribution SCADA. What is SCADA? In form of SCADA, supervisory control and data acquisition. SCADA is a relatively mature technology for the management of distributed asset systems. It has been widely used for the management of generation and transmission systems. They are increasingly being employed for the monitoring and control of the distribution system. So the upcoming technologies are support the deployment of SCADA technologies are still occurring, particularly in the communication area. Here, the below figure illustrates the major components of a SCADA system. This SCADA having the combination of both hardware and software. It is typically located centrally at the control center. So what are the components are there in the control center? The control center consists of the SCADA application servers, communication front-end process, data historian, interfaces to the control systems, operator workstations, and other supporting components. Here, the primary SCADA system is often redundant. Along with that, we need a backup. We need a backup with the primary data and the backup. So other system, so it not only communicates it to the components, it has the primary data and the backup data. Other system environments are also installed and they are also utilized for the testing and quality assurance and deployment and training of the distribution management system. So coming to point of various types of communication links to the remote terminal units are used. These communication links are now becoming more IP based using protocol. So these communication systems are work based on the IP. So internet protocol. So internet protocol based on this IP address, they are all communicated. They are all communicated. That is about the distribution of the SCADA. And next coming to point of see that in that figure, so it is one of the application of the SCADA for distribution system. Here, SCADA is nothing but it is not a single component. It has both hardware components and software technology. Here, along with that, here SCADA is not economic. Here it is a costliest one to manage the distribution system. Here, the cost of additional sensors, IEDs, RPUs, communications, and SCADA master station. So might be related to the benefits that are realized. So it is not very economical, so rarely economical to monitor and control an entire distribution system. See that here in that figure from the remote station, this is the SCADA. See that in that figure, he is the human mission here, human, that is the operator observing in the computer, human mission interface. And next one, these are connected to the communication links. So these are the communication links. So we are getting the communication to the radio or microwave. And next one to the mobile phone or optical fiber wires. And next, this is the remote substation. Remote substation. So in that substation, we are connecting the actuators, meters, accumulators, and program logic controllers. They are all collecting the information of the substation. Information of the substation. So that is about the SCADA. And next, come to the point of what are the trends? What are the trends in distribution SCADA and control? The trends in distribution SCADA control, very important. So what are the trends are happening in the distribution SCADA and control? So SCADA is nothing but, so where we use the SCADA in the master station or control center. So these, see that here, this master station developments, this master station developments, it is the one of the technology. So one of the technology SCADA. And next one, while adopting the technology of SCADA in master station, here that communication having the increase of the bandwidth. So what is the bandwidth? Bandwidth is nothing but the range of frequencies. That is the transmission of signal with the how much amount of speed. The transmission of the signal can be measured in terms of frequency. That is trends in the industry is the increase of bandwidth from the substation to the control center. And not only here the transmission of the signal from the substation to the control center observation, and also along with the monitoring and control points of the distribution network to the control center. That is the first trend. So in master station developments, and along with the increase of the bandwidth of the transmission of the signal information from substation to the control center, and monitoring the control points of the distribution network to the control center. And next one, so due to the increase in the bandwidth here, the proliferation of the low cost sensors are also deployed. We are increased on the network to increase the monitoring and measuring capability of the SCADA. Here, the latest trends in the SCADA is we are going to increase the bandwidth. When the bandwidth is more, within a fraction of seconds, we are getting the signal or we are getting the information, which will, so this high speed of signal enables the components in the master station. And next one, more complete view of the network. So due to that, we are increasing the accuracy of the calculations and predictions. So for example, the transmission of the data will be very low speed. So then here the data, that the energy, that is the information can be transferred to the control center with it takes certain times in minutes or seconds. So in the delay time here, some problem are occurred. Okay. And next one, due to the exponential rise in the real-time points, here the old capacities of the SCADA will be left behind. By adopting the latest technology, we are using the latest SCADA technology. Okay, due to that, we are improving the performance and standards of the substation. And next one, how this is possible? This can be aided by the CPUs. What is CPU? Control processing unit. So this control processing unit having the one of the device RAM. What is RAM? Random access memory. So they are very cheaply available. They are collecting the information. They are storing the information. So along with that, here with that RAM, we are storing the energy. So that is with the help of the software system, we are improving the trends in the distribution system. And next one, along with that, one more point, the more accurate modeling of the distribution system. So by the arrangement of these CPUs or these are all, the more accurate of the distribution network. And next one, how this can be accurate with the latest technology, we are enabling the distribution network by the optimization algorithm. So these optimization algorithms to run, reducing peak load and differing investment in the transmission and distribution assets. Next one, many localized fault locators will be able to be deployed to accurately locate faults and enable the restoration to occur. So these significant changes also seen in the area of the database management and the reduction of the configuration cost.